Hi there, welcome to www.highschoolmaths.co.uk. Today we're going to be looking at fractions in context. And what it basically means is we're going to be looking at worded fraction questions. So it's really a continuation on from your basic fractions work where you're given the fractions questions directly and you're just looking to build on them. For this kind of question here, what we're doing is really looking to see how do we approach the question. So you know your four operations, you know how to implement them already. So if we look at the first example here, calculate the area of a rectangle. What you've got to think about is how, okay, yes, it's a rectangle question, it's an area question, but it involves fractions. You still deal with it the same way you would normally deal with an area question. So to find the area of a rectangle, we know the formula is the length times the breadth, or some slight variation on that formula. So what we're really looking at is 1 3/4 times 3.5. Okay, so basically this question is telling us to multiply those two fractions together. And once we establish that it's a multiplication question, we just go through that exact same process that we've done before. Okay, so if we start off making the fractions top heavy, or improper. So 1 times 4 is 4, add on to the top is 7, so we get 7/4, times 3 2s are 6, add on the top is 7, but 7/2 this time. Okay, and a rule for multiplying fractions is top times top and bottom times bottom. So 7 7s are 49, and 4 times 2 is 8. There's no simplification we can do here with numbers, but we're just going to make that back into a proper fraction, or sorry, a mixed fraction now. So we've got top heavy, 49 over 8. We want to figure out how many 8s go into 49. So 8 6s are 48. So that would be 6 with the remainder of 1 over 8. Okay, so that would be your final answer. And because it's a question in context, we want to put units into the final answer as well. So it's square centimeters for our units. Okay, so that's the area of that rectangle, which looks roughly like it should be if you look at the dimensions given, 3 and 1. So we're talking about almost 3 times 2, which kind of ties into the 6 that we've got there. So that seems like a reasonable answer. Okay, moving on. So we're not going to go through a massive amount of these kind of questions because it's just figuring out how you're going to approach them so you're not put off, because fractions do scare a lot of people and there's no real reason they should. So if we look at this one, we've got a rope that's 6 1/3 meters in length, a piece of length, a piece of rope, that should say, rope, 2 2/5 of a meter is cut off. How much is left over? Okay, so again, really you're thinking about, is it multiplying, adding, subtracting, dividing? Which one is it? So here, I always find it easier to think about it as whole numbers. So if we had ignored the fraction part there, if a rope was 6 meters in length and a piece of the rope was cut off that was 2 meters long, well, you just do 6 take away 2, and that would tell you there's 4 meters left over. And it's the exact same thing you're applying. You're applying that, but you're doing it with the fractions. So you're doing a subtraction calculation. So you're doing 6 1/3 minus 2 2/5. And that's what we really want to establish here, is that you've got to decide what your operation is going to be. Sometimes it's going to be more straightforward, sometimes it's going to be more tricky, but if you try and think of it as what would I do if it was whole numbers, it often makes it easier to kind of visualize in your head what's going to happen. So here, a few different ways we could approach this. So it's entirely up to you what you would want to do. When I go through this, I tend to make them improper fractions again, but you can just do the 6 take away 2 if you've been shown that method, and that will work as well. So I'm going to make them into improper fractions. 6 3s are 18, add on to the top is 19, so it's 19 over 3. 2 5s are 10, add on to the top is 12 over 5. Now, with the way I'm going through this here, it's going to give some bigger numbers, so as long as your numeracy skills are fairly sharp, then you should be okay with that. We need a common denominator, so that's going to be 15. If we look at the denominators there, 3 and 5, the lowest common multiple of 3 and 5 is 15. Multiplying the first fraction by 5, so 19 times 5 would be 95. And multiplying the second fraction by 3, 5 times 3 is 15, 12 times 3 is 36. So when you subtract that, you get 59 over 15. Okay, again, that's not going to simplify, and they're not in the same times table. So we're going to jump straight into how many 15s fit into 59 and make into a mixed fraction. So how many 15s fit into 59? That would be 3 with the remainder of 14. 3 15s are 45, plus the 14 takes to 59, and that gives us the 15. And it was meters of rope. Okay, now there's an endless variety of questions. Basically, any whole number question can be translated into a fractions question. So, fractions are something you're going to have to deal with in a variety of different situations, especially as you progress through your maths. And it's important that you're confident with them. There's nothing really to be scared of. There's 4 operations that you have to remember, and it's just how you apply those operations in different orders and different contexts. That's just the only trick to really getting good at fractions, is just recognizing what you're going to do. So hopefully you found that helpful. Hopefully that's a bit of advice to help you through some of those trickier fractions questions. If you like the video, please remember to click that like button and subscribe. If you want to see more videos or look at any resources, worksheets, please visit www.highschoolmaths.co.uk. And thanks for watching. Have a mathemagical day.